നൗഷ ടീച്ചറെ ഞാൻ സാറേ ലൈവ് സ്ട്രീമിംഗ് സ്റ്റാർട്ട് ചെയ്തിട്ടുണ്ട്.
ഓക്കെ, നമ്മൾ എക്സാക്ട്ലി 7 തുടങ്ങാം.
ആയിക്കോട്ടെ, ഞാനത് ചെക്ക് ചെയ്യാനും
പോസ്റ്റ്
കൂടെ
ടൈം 7 ആണ്.
ഓക്കെ ആണ്, അത് ലൈവാണ്.
താങ്ക് യു. Shall we start, sir? 7 o'clock. Hello, am I audible?
Yes.
Shall we start, sir?
Yes, no, Raja, we can start.
So good evening all. A warm welcome to the Gloria Gopi Kumar annual lecture jointly organized by the Department of Electronics and Communication Engineering and Alumni Association of GCT. To introduce myself, I'm Dr. Naushija, faculty in Civil Engineering and currently the Secretary of GCT Alumni Association. The annual lectures were conceived to commemorate the late Gloria Gopi Kumar, an alumna of 1984-88 Electronics and Communication Engineering batch of GEC, and this has been initiated by her classmates and friends. The first lecture in this annual series was delivered on 21/2020 by Mr. T.N. Santosh Kumar at the Gloria Gopi Kumar Alumni Hall of GEC. It was on the same day that the Gloria Gopi Kumar Alumni Hall was inaugurated by GEC's own prodigy, Dr. Tessie Thomas. As known to all of us, the erstwhile Western Amphi of GEC was renovated using a contribution of Rs 50 lakhs received from Sri Krishna Kumar, husband of Gloria, and the hall was renamed as Gloria Gopi Kumar Alumni Hall. The second lecture in the series was delivered by Mr. Ganesh V. Iyer in January 2021. This brief intro was just to give an insight into the gesture of love and affection rendered by friends and family members of Gloria, who has been my batchmate as well and a dear friend close to heart. And this year, the lecture is being delivered by Dr. C.V. Jawahar, an eminent alumnus of GEC who belongs to the 1991 batch. The speaker will be introduced to the audience later, but before that, let's listen to a dear friend of and classmate of Gloria, who will share his fond memories of her. We have with us today Mr. Narayan Bhattatiripat, an alumnus of the 1984-88 ECE batch. He is currently the Senior Director of CAGO Incorporated. Over to Narayan for sharing the memories. Narayan, please.
Good evening, everyone. You can hear me and see me, right? Are you able to hear me?
Like audibility korchu koravundu, Narayan. Like,
okay.
It's fine. Now it's fine. Yeah,
okay.
It's fine now. Yeah.
Okay. Yeah. I'm Narayanan. As Naushija said, I'm alumnus of GCT, passed out in 1988, Electronics and Communication.
I think you have to keep that thing a little more closer to your mouth.
Is better? No? Let me just
wait 1 minute. Is it audible now?
Yeah, it's fine.
Oh, yeah.
Okay. Yeah, thanks. Yes, sorry about that, some technical problem. So, as I said, I I was studying in GCT, 1988 batch of Electronics and Communication. I'm here to introduce Gloria to you, the person in whose memory this series of annual technical lectures are being conducted. For most of us here, Gloria needs no introduction. Many of us knew her in person. People who attended the last couple of sessions already heard about her. But there may be a few students and others who are attending these series of lectures for the first time. So my talk is mostly for their benefit. As you know, Gloria was an alumnus of GCT. I was her classmate. We were a small set of 16 students in the second batch of Electronics and Communication in Thrissur. So it was a small group, very close-knit group, very close friends. We are still, all of us are still in touch. And after passing out, Gloria got married to Krishna Kumar, and they migrated to US, settled there with their kids, Sita and Rohit. And she joined Intel those days. And I consider that as a big achievement, because even those days, Intel was a very prestigious company, but not as big as it is now. So she joined at that time. Just to give you a perspective, you know, the IT boom was not yet there when we all passed out. Infosys, for example, was a small company of a couple of hundred employees probably. They still had their first office, a small house in the residential area of Bangalore. So during those days itself, she got into Intel. And by now, she would have grown to a very top position there, but the cruel fate had other plans. On 4th of November, 2013, 5th November in India, she passed away suddenly at her home. Gloria was a dear friend to almost everyone who got acquainted with her. She had always had an endearing smile. She used to interact and chat with people, giving them a feeling that they knew each other for many years. That was her characteristics. Whenever we visit her house, her hospitality was always memorable. So many people, she had many friends, very close friends, and all of us were in deep grief and shock when we heard the news that day. It was like a close family member passing on. There's a famous quote that God's plan always has a greater purpose. But in this case, we can never justify his plan that he had for Gloria. Personally, for me, Gloria was a very close friend, one of very, very close friends I have. Our families had a couple of common friends, so that brought us closer together. And we kept in touch even after college. Those days, communication was not as easy as these days. So whenever I used to visit US, I used to do that frequently those days on official matters. I used to call her from wherever I am and chat with her on phone for a long time. And whenever I visited the Bay Area, I used to visit her house and my classmate and friend Thomas's house also, and stay there. I used to make it a point. And whenever I visited Gloria, Krishnan, Gloria, and I used to sit and chat for a long time, hours, for about everything under the sun. And Gloria always used to be so bubbly and excited, and she more than compensated for my inherent reclusiveness. So she always caring and considerate to all of her friends, and including me. She visited me, called me, supported me when a couple of times I went through difficulties in my life. So she left me with a lot of sweet memories to cherish until we meet again on the other side. Krishnan did a very appropriate thing by funding the renovation of our amphi into a full-fledged conference room with all the technical facilities for having online conferences. And that amphi is now given Gloria's name. And these series of technical lectures conducted by our department and Alumni Association definitely will help to make Gloria live in all of our hearts forever. Her name is very unusual for a girl who was brought up in Thrissur. We used to joke about it. But now I feel that is the most appropriate name she could have. The meaning of Gloria is eternal glory. And she is that for all of us. Thank you.
Thanks, Narayan, for sharing the memories of our dear friend on this very occasion when we are celebrating her legacy. Moving on, let me now take the privilege of introducing our guest of honor and speaker of the day, Dr. V.V. Jawahar, an eminent alumnus of GEC who belongs to the 1984-91 batch. C.V. Jawahar is the Amazon Chair Professor at IIIT Hyderabad. He received his PhD from IIIT Kharagpur and IIT Kharagpur and has been with IIIT Hyderabad since 2000. At IIIT Hyderabad, Dr. Jawahar leads a group focusing on computer vision, machine learning, and multimedia systems. He is also interested in applications of AI in road safety, assistive technologies, healthcare, education, cultural heritage, and entertainment. He has served as chair of many international conferences in the past. Presently, he is an associate editor of CVIU, IJDAR, and IEEE PAMI. He is awarded the ACM India Outstanding Contribution to Computing Education in 2021. He is a fellow of IAPAR and INAE. Today's lecture is titled, Can Computer Vision Disrupt Sports? With this very brief introduction, I invite Dr. Jawahar for the deliberation. So please.
Nandi, thank you for the kind introduction and far more inviting me to give this talk. It's a privilege to get connected back to GEC and the friends, peers, the senior students, juniors, like all of us. So I was part of the 5th batch of ECE, where we had rare privileges of seeing the seniors, giving them farewell, bringing them back to the classroom as teachers. So we had a nice connection to people in that batch, people like Vrinda and others. Then we moved on. As Narayan mentioned, we were also possibly the pre-IT boom, an era possibly like people don't connect today. And I had a different journey, like I went continuously, say, for higher studies and continue to do research and teaching. I enjoy. So I work with students, I work on various research problems. And what I missed today is possibly like I would have liked to see it happen this lecture on campus. Seeing the buildings, seeing the classrooms, good old friends, and a lot of things to remember again. But we are in a situation where we cannot do. So we'll look for a better opportunity. So today's lecture is, when Jain and Vrinda invited, I thought I will keep it at a level which a little bit popular lecture, semi-technical lecture, where people with different background can appreciate, maybe students, junior students, the current students, can look at more technically. Maybe old people, retired people can enjoy where the world is moving and enjoy some pictures, nice, cool pictures, etc. So that's how I kept it as a very popular lecture. Feel free to interrupt me. You can ask a technical question, non-technical questions. I would like to see more personal interaction. Unfortunately, I don't know how much we can do in this online Zoom settings. Okay, so with this background, let me get slowly into the business. So the topic, I'm in Hyderabad. I can see my Hyderabad, you can see possibly my Hyderabad bias on the title itself. So what we want to look at today is we have been hearing this a AI wave, or AI is touching everywhere. All of us talk about AI, all of us do AI, all of us practice AI, all of us carry AI in our pockets. Let us see where we are and what could happen as we move forward. That's how I would like to place this. So I want to give a perspective on what is AI, because it could be very different for many different people. So I look at AI from an angle as a technology that can impact us, the society around, in the coming years. So to give that story, so he look at what we have done over the last many years when we had this a .com, IT revolution, this, that, many things that we have been seeing in the e-governance, mobile phones coming everywhere, remote sensing. So we created a lot of data in different forums. So when I say we means as a community, we created a lot of data. Now we have a lot of algorithms and areas. So I think people teach these subjects in classrooms. People practice this and write research papers on these topics. But what we really need is something else. As a country, what we need is how we use this for solving problems that matter. Solving problems that are relevant to the society, to the larger community. So this is the large story that we are seeing. Though we may say that, oh, AI is all today deep learning, or so you can have a very narrow perspective on this. But there are minimum things that we all agree that this is touching us. So how is it going to touch us in the next coming years? The top layer will tell you possibly how this is going to touch you tomorrow, if not already. So just to bring this narrow down the scope to say computer vision or a specific theme. So I just want to look back and see what we were what we were doing few years back when we were traveling, or when we were when we are living. Now we cannot live without a mobile phone. And a number of applications today are made smart by a simple sensor, GPS. As a sensor that just provides you very minimal information. And we know how complex this technology is. I'm not saying this technology is complex, but the information, say technology is simple, but what it provides is a very simple information about your location. And that itself has changed the way we practice and we live every day. I think every day we use this for something or other. Speech is already here. The next level of complex sensor, speech, we all use, at least say many of us use, at least the next generation, even if we don't use, we see the younger generation at home, younger generation comfortably using the speech technology. Let us be ready for the vision. So we carry a big camera with us, a powerful camera, now multiple cameras. Earlier it was one camera, then it became two camera. I don't know now how many cameras you carry in your pocket on the same device. Is it only for taking your personal photographs? No. So we have not started to see the powerful applications of it. And that is going to be possible, one of the big things that could happen very soon. Maybe with your mobile phone cameras, maybe with the cameras that we see everywhere else in the world around us. So the AI, you can look at this today as AI, the interfacing with the real world. So you have, if you want to look at the traditional, the classical way of AI in terms of knowledge, representations and reasonings and making decisions and or whatever the AI you had studied 10 years back. If you ever want to use that intelligence in the solutions, you need the knowledge to be captured. And we are seeing a lot of things, interesting things happening with text. Lot of interesting things that happen with speech or audio, and a lot of interesting things happening with images and videos too. So this is where the AI, the people look at AI, don't look at AI today as the age-old AI that we know, and a very narrow view of it as some specific machine learning algorithms or specific programming languages or specific software hardware combination. So this is the way the AI is going to be touching us, and it is going to impact us. We need to drive this. We need to use this for many interesting and innovative use cases. So for me, I thought this talk can be is organized, keeping multiple different categories of people in the audience. So for students or fresh graduates, it could be just fun. Like I see some nice cool videos and remember some old sports situations that you read or you had enjoyed on TV. But one thing to note is, this is also telling you how do you solve problems in real world with limited resources that we have. So we sometimes complain, look, I live in a place where I don't have access to. I don't have access from teachers who help me for solving these problems. I don't have supercomputers that are required for solving this problem. So we all complain about we don't have resources. No, a lot of things can be done with small, limited things that we have access to. We just need to be imaginative. And I'm sure there are a lot of entrepreneurs and practitioners in this crowd. At least, if not today, many of them will become entrepreneurs and practitioners in the future. So I also want to trigger a set of thoughts on what type of opportunities could come up soon. And how do you get ready for that? And we also have a number of teachers and researchers in this team. So how do you balance between theory and applications? So we teach students. So we also need to see how do you connect what we teach to the application that they appreciate. How do you say, and full life cycle of research. Say how we work with students on problems, research, technology, papers, patents, practical users to products. So how this sort of full life cycle can be thought of, and how do you, so I also use this as an example to show how do you go through a full life cycle of research. And of course, for sports lovers, I feel bad sometimes. Is the tech going to spoil the sports? The naturalness of it, the thrill of it. Are we going to lose it? Maybe. I don't know. This become more and more artificial. So just to set the background of this, what we are talking about, what is this gap that I'm getting into now? So we know the chess as a game that possibly had the most or the influenced by AI. And we had seen its impact. We have seen grandmasters coming in different parts of the country. We had seen people getting trained in remote villages. We had seen people doing well by training themselves on small mobile phones or computers. what is the next level of AI touching sports? One important thing for anybody in ECE or EE, you need to appreciate or you need to think of, you should close this cycle. You need to have a feedback. You should be able to close this. A bowling machine will have to know the weakness of the batsman and throw the right set of balls so that the batsman improves. We don't have that today. It's a big opportunity for using the technology that we are learning to get to use in the field. It's interesting to see why we don't have that. I possibly will not try to answer that question, why we don't have that enough at this stage. I'll hint here and there. I have my own views on it, why we don't do that. But these are technologies that are possibly not too far for us. So the smartest bowling machine that we may have today possibly may have a timer, a 555 timer that possibly I don't know which semester we teach that now today, third semester student will be able to do. Why don't we build smarter machines? Why don't we use it for teaching players how to play better? Just like, of course, see, I'm sure some of you may say that, okay, no, oh, this is an interesting idea you can do. So just ask a reverse question, which I don't want to open today discussion about why the Courseras are not replacing the teachers. Okay, so there is a teaching aspect here of sports, and there is a need of technology, and there is a need of feedback, there is a need of closing the loop, there is a need of controlling, there is a need of nicely designing full system, hardware, software system with human in the middle. And it's a very good exercise to try for the new people. Okay, so why are we talking about this today? And what it can do? Of course, improve the broadcast viewer experience. I'm sure if you can do anything in that space, I know you all know how much money it is. Improve the training of professional sports person, democratizing sports education and training. So you go and see what happened to the history of, say, cricket in India or any game in India. Football. When did you start to see people coming from the rural India into the national team? What triggered it? One thing that we all know is the sports facilities that are distributed across, but far more. So now if you want to take to the next level, the super special coaching skills that we have in the pockets today, how do we take it to the villages? And in a country like ours, where talent is available everywhere, but opportunities are possibly missing because of the population, because of the crowd, because of the economics, many other reasons, socio-economic issues. Can you see how technology can break this today? It can scale. And of course, now once you are able to break this, like you are able to close this loop, you can bring in strategies, you can bring in nice algorithms. Why now? Because we have started to see the success today. So today's talk is mostly centered around this use case in sports, and there are similar use cases in other areas too. So I'll center today on sports as a vertex up. Just before we get into the sports, I just want to give like a couple of minutes on introducing computer vision for people who possibly may not be familiar with computer vision or image understanding. So the goal of computer vision is to understand images and videos. And understand is a very loaded word. What does it mean by understanding this picture? So the way to this tough word of understand is practice today is by breaking this down into subtasks. For example, I should be able to answer questions like how many cars are present, or how far is a building, which make is a car, or where is this tree, or how many trees are there. So this sort of like a subtask, like seed classification, object detection, pose estimation, semantic segmentation, a number of technical sub areas emerged. And today, computer vision tries to build an understanding by solving these problems. And to technically explain, because I'm hinting some of these keywords in the later part of the lecture. So what is classification is, like, given a picture, I should be able to just say it's a steel drum, an example here. So next powerful understanding of it is to say, where is it? Say, for example, I should be able to draw a box around a person and say, oh, here is a person. Or still deeper understanding is, I should be able to draw every pixel on it, like a photoshopping, and say that, okay, here is a bike. So over years, we had seen successfully the computer vision problems shifting from the left to right into the newer and more challenging task. And now people talk about, can I generate? By claiming that generation is like a skill possibly requires far deeper understanding. You can differ with that. And this is done with the help of what you call today the data-driven intelligence, where in 2003, when people wanted to formulate the problem of, I want to classify, say, 100 object categories, 100 objects like elephants, tigers, footballs, tables, chairs, what we all see every day. They just went ahead and took pictures of so many different type of, say, for example, chairs, and told, can now a computer learn to say what is chair? Or what is an elephant? Elephant may be seen from different angle with different background. So, but still a computer should be able to say that's an elephant. And people thought in 2003, this is a very, very difficult problem that is not going to get solved. And now today, the performance on standard benchmarks in this space is in high 90s or very, very high. People don't worry too much. So people moved with the challenging task or with other data sets. So in a way, this benchmark data sets became the driving force. The data sets defined the problem, and data sets defined how the community is performing today, and systematically know how when we break some limits of like a performance, the practical applications start emerging. Industries start to pick use cases, practical use cases in the field start to come up. And so this is how the research versus practice has been developing over years. And in the middle, like, there is a big data set that was collected, ImageNet, that became a fuel for the evolution of today's deep learning, the convolutional neural networks, recurrent neural networks, deep learning, etc. Because this was a huge data set that was created, possibly not thinking that this is going to trigger deep learning, but it was possibly instrumental in seeing the birth of or the success of today's AI wave. Okay, so now the perception or the understanding word. So this was bothering researchers for many years. And the question was, I show a picture and I want to know what you understand out of it. So this was an experiment done by, like, the people who work in perception. So what they did was, they did a small experiment. They just showed that picture to people for, say, 40 milliseconds and asked, tell me what did you see in that picture? Or 80 milliseconds, or 100 milliseconds, or 500 milliseconds. And as you can guess, if the picture is flashed in front of you for more time, you are able to understand more what is there in that picture. So in a way, we thought that the capability to explain is a measure of understanding. Remember, look at the year. So I'm putting a lot of citations at the bottom. So these are research papers that were published in journals and conferences in the past. And so if the people anybody want to know more technical details, is a place to refer or look for. So this tells us what is understanding. The loaded word understanding was explained by saying that, look, I can explain that in a human understandable language. I don't know whether the text itself is sufficient as an understanding, but at least that is one level of understanding. So this issue between the vision and language, or the picture and text, or computer vision and natural language processing, that became very interesting pair which advanced together, where people started to talk about, like, I can answer a question of, like, I show a picture and ask a question, can you give me an answer? So you should be able to now, just like you ask questions in Siri or like Alexa or wherever it is, like you should be able to ask questions on visual data. Your album, you should be able to retrieve, you should be able to process. When you travel on the road, you should be able to ask a question rather than you trying to read it. So there are a lot of interesting applications and use cases, a lot of assistive applications. People who have difficulty for seeing can ask questions and get the right answer without worrying about what is there in it. So seeing, understanding and providing answers. So this issue of this metric was defined. So this is, I'm just setting the background for telling you that a measure of understanding is today.
Comes out.
Now we started asking this question of what.
Oh, quite an extraordinary shot. It's out of the park. Absolutely extraordinary. 6-6. And what a 50 that has been.
Indeed, the players and the jersey tells you the era where this video was broadcasted. So the question here is now, is an AI algorithm or a computer vision algorithm capable of looking at this video and telling the paragraph that is written on the other side? Surprisingly, even today we are not. Okay, but we solved this problem in 2008 or quite some time back. So this was we had a smart student who solved this problem even when the AI algorithms were not ready to solve the problem, because we found a very, very, very smart trick that this solution to this is available in another place. The question was getting streamed on television, while the answer was getting streamed on the internet. And in those era, both of them were coming on two different cables to home. Today, possibly they are coming on the single cable. So you have two different streams which don't talk to each other. Is there a way for you to talk that you can force them to talk to each other so that the problem is solved? So this was quite straightforward, because once you have this smart solution, so what you need to do is possibly very simple. You need to understand both of them as two sequences. One is a visual sequence, one is a text sequence, and you need to use a very simple algorithm called a dynamic programming or dynamic time warping. People in who have studied algorithm will know, people who have studied speech processing will know something like a dynamic time, signal processing. People who ever worked on time domain signal processing will know dynamic time warping. So you can look at this as like a very, very simple algorithm which can solve this problem. So once you have solved the problem, what does it mean? Once you have solved the problem, now you know what is happening in every piece of this video. You understood, you solved the problem, be happy. So you can build now a lot of interesting things. I can now start building a search engine on top of it. You can give me show me where Srisanth was bowling and to somebody in this match. So I can give you all the search that you want on large video repositories of cricket videos. I can use it for learning. I can use it for strategizing. So I can build highlights. So a lot of things that requires human intervention can be enabled on a large video repository. So this was cool. But the problem with this is this works because a human has written. If I give you a new video clip where the cricket for commentary is not available, I don't have an answer. I'm at the mercy of the guy who is sitting and typing there for giving this solution. So this was bothering for many years. So we thought we want to solve this problem without somebody sitting and writing the commentary. But then the cricket was super complex game to play at that stage. So the video, the dynamics, the commentary was very powerful. We went and tried this. Okay, can you try this on, say, tennis? Where the video was much more stable, like a camera was not moving that fast. Video was more less noisy, very more nicer to work with, easy to work with. So we looked at what a captioning algorithm could have done. Like I showed you a little before about this captioning. The AI algorithms are trying to write a sentence about it. So that could have written a group of people on a tennis court playing tennis, completely useless for the purpose. So what we want is something like, say, Serena Williams is doing this. A powerful description that the tennis fans will appreciate. I can build search engines on top of it. I can build the solution, teaching aids, streaming aids, translations, and many other things on top of it. So this was possible in 2015 because by then we have we were able to design the better understanding because it's a narrow domain. So how do we cast this problem? So the problem now can be thought of today, like today's AI. You have a lot of examples. You have video clips and the corresponding commentary that the fans have written on internet somewhere here and they're available for crawling. So you have now like a text and you have a lot of examples from the past. Now learn from this data and build a capability for predicting a paragraph for a new clip that is available. And this worked. This worked because we could now break this problem into understanding of, say, players, who is a player, what this player is doing. There are only few things that they do on the ground, a limited number compared to possibly the cricket video that I had shown a little before. And you look at the actions, you look at their positions, you can understand the geometry of the code, and you can create text, you can synthesize text out of it. We use possibly a lot of bits and pieces of like a machine learning and computer vision and language processing. Possibly the today's deep learning was not used, and it worked. So here are a few examples. So these were not written by humans. These paragraphs or comments were written by like a machine. So we've seen what we could do in the initial cricket attempt and the tennis attempt I had shown you. Now let us understand. Now we have some level of understanding of this. Can you use this for like a deeper understanding of this? Now, what is deeper understanding? So you can have macro or a higher level understanding of what is going on in this, like a seva coming and hitting something, etc. You can say. Can you build a micro understanding or a one level deeper understanding out of it? In terms of who is this Rahul Dravid in the middle of the game? Or who is this Virat Kohli in the middle of the game? And what is this guy doing? And what do you mean by, say, cover drive? Or what do you mean by a hook shot? What do you mean by a sixer? So you want to build a finer understanding out of it. And interestingly, this is now, so you can propagate this knowledge from the video clip description to the next level because you have a model for it. You have a grammar. You have a structure for this. There's a bat. Say, if you look at cricket, like there's a bowler coming and running and throwing the ball, doing this. There's a fielder. There's a set of things that happen until this entire thing is completed. You can move from one state to another, and then finally reach to the beginning. Like so, you know the structure, the possible ways in which this can go, and use this knowledge on top of the video and the text. So that now you have understanding of every small piece of it. This worked. So this worked in the building. Like so, for example, now you are able to say what is Pollard, what is Gale, what is a short, what is a short ball, what is a pull shot, what is a deep mid wicket. A lot of deep technical words within it Now we are able to get examples and understanding from these videos now. And you're able to get now the video annotated at a very fine resolution. So you can now get only the, say, pull shots, or only the drives through certain field positions, or only the drive by certain player in this way. So a lot of very interesting, very fine resolution you are able to build an understanding now. This was useful, and I'll show you a few more examples. So you are able to, now from a big paragraph, now you are also narrow down the understanding and the captionings and alignments and descriptions to a phrase sometime, or a long phrase, and say what is really going on. This was very nice. Like, it worked well, and people appreciated suddenly. Like, oh yes, people thought that this got good visibility. So people thought that we are possibly going to change the way what this world is going to see in terms of the sports, where the vision or AI, before the AI, like AI was not used in this period. How the computer vision is able to change things. And indeed, this was acknowledged by people.
I mean, I was reading the paper from your computer vision folks, where they were analyzing, I guess, auto-generating cricket commentary, and even figuring out Rahul Dravid's technique by doing computer vision. And yeah, that's right. Essentially they figured out that his straight drives improved over the period of his career. So that kind of technology, which I think is going to be pervasive. It's going to be true if you're in agriculture or healthcare or energy or retail. There's not going to be an industry that's not going to be shaped by statistical machine learning. And
so I hope you can hear the audio. Yeah. What we saw today till now is this understanding from of soccer, say, of the cricket, and we saw something in the space of tennis. I'll come back to that a little bit later, of the racket games. So let me see what are the equivalent problems in soccer. So today, if you want to look at the soccer, like possibly one of the very, very popular game, highly watched game, a lot of interesting things happen. But at the end of the day, if you look at what you see is very limited view of this field. If you ever want deeper insight into it, what you need is something like what you see on the right-hand side. You need to know which player is standing where. That alone is not enough, actually. You need to know where this player is looking, where the ball is, and how can you do the passes. So a good, interesting exercise, those who want to take this sort of technology forward, is to see now, from here, can you make prediction what could be the right strategy to attack? How do you use your intelligence? How can you be the nice, the armchair critic and say that, no, this you should have been the right shot to play for that people. Right pass could have been this, right strategy could have been this. You can criticize post-match. Can you suggest this? Can you recommend this? Can you calculate this? Can you predict this? What are the different ways where somebody could have scored a goal? If you ever want to do that, so how do you process this data to get this? That's an interesting problem that we want to tackle. Today, there is still a very, very, very good open problem. If anybody want to look at this as a future research problem, is about, can you predict the players that you don't see in the field? Where are they on the field? So you see only a set of players in the field of view. What about the rest of the people? So you need to be intelligent if you want to make a right guess where they are. You need to know the sports domain. You need to know the game. You need to know the strategies. You need to know the teamwork to know where the person will be standing at this moment. And that intelligence, if you have, you can start guessing and making predictions on things that you don't see. And people will be surprised and people will say that, okay, you are intelligent. Okay, so how do you do that? So this was done by looking at a picture. You want to know where this piece of game is. Most of the time what happens, this camera is zoomed in. You see only a very, very narrow portion. You don't know where is it. And you should be able to still make a guess of where this camera is focusing, so that you know how you can start get the aligning. So just you can see the video, and according to the video, one should be able to start and predicting what area you are seeing. And using this prediction, one should be able to identify the players, the type of players, the player's name, player's jersey, player location, and then start putting them on the map. So here you can see some examples. So the blue area is where the camera is looking, and then try to match, try to put the right people there and create the view. So this sort of automatically processing this is a way of building a strategy. So you can now see how the AI in the chess, or how AI in any other domain that you're familiar with, the strategies could be now applicable here. Maybe post-match analysis, maybe planning ahead, knowing the limitations of the people, knowing the preferred moves of the people. So we see a lot of things now, human learning, and certainly the human coach, the journalists, the fans, they know a lot. And I think there is a lot more can be learned from the data today. So what we want is, the idea here is to build this data for strategy and planning, something like this. So this is what we have tried in the sports space, so the soccer space. So let me come back to the racket space, racket games itself. So we talked about the racket games, the tennis story. So if you look at what changed, so I made this remark a little before, that the game, where the technology touches the game, I think it has not moved as much as we all could have thought of. It's a good example. The Guardian says that in 1999, the game between Sampras and Agassi, and 2017, Federer versus Nadal. I think what changed between them possibly is only how the display. It was possibly now an electronic display. Earlier, it was possibly like a mechanical human was going and putting the numbers and writing this. Or the display style might have changed from 7-segment displays to LED displays or something like that. So the content has not changed much. The information that we extract out of game has not changed much. The analytics in such games have not changed much. This is unfortunate. Enjoy. Beautiful game. But how do you know what is going on in this? This is important for us to make it. Okay, so now if you look at that video, other than just watching, what else we should have done? There are a number of questions we should have found answers automatically. Who dominated? How many shots were played? Who played at what time, what shot? Where was which player at what time of, say, in the game? How much distance the player ran? What speed the player was running? What could be the calorie burned by this player? Will this person get tired in this many rallies or this much time? Lot of interesting, important strategic questions. Answers could have come from this. and what somebody should do. Unfortunately, we don't do still this. The coaches may do a little bit with pen and paper, or with limited technology or limited resources that they may have, or with their experience. If that is a state in Wimbledon's or Olympics, what could be the state in our local neighborhood? Who is telling our next generation players in our local neighborhood how to play a game and how to prepare, how to get ready for this? There is no support. So we thought this problem is interesting and we should see what we can do. So we thought of picking up a game where we can try to make some dent. So here's an example video where you can, I don't know whether you can read here at the bottom. So you can see where the player is standing. So you can see the heat map getting generated on the right-hand side, where the player is standing, what the player is doing at any point of time is captured here. So if you see the things pattern that is emerging on the right-hand side and the shots, you know that a lot of things that we discussed in the previous slide can be answered. How much the player has moved, walked, ran, what speed, what force, what trajectory, where the next the counter-attack was done. Like, so hundreds of interesting sports questions and strategic questions could be answered from the data that you see on the right-hand side. So what was missing is this piece. As I was mentioning in the beginning, when this sort of nice, beautiful things that we see in the real world, and we understand the other end of the story of the right curated, nice data and how to use machine learning on top of it. We understand the transaction histories and credit card histories and the databases which tells you what is going on in a shop and predict, plan what is it on top of it, the type of data mining that we talk about. However, we don't see that the same thing is applicable here. This is the gap that we need to bridge. So this was this was done, and in the lab. And then if you look at this was possible because if you look at this now, there is a nice resolution, there is a nice grammar, there's a nice structure, what the players are doing. So the full video where the point segments, and each point segment there are people, somebody serving, there's a reaction for this, what type of shot, what happens, who finally becomes a winner. So there is a nice, interesting explanation that you can build out of it. The moment you build such a description, I think then like you say, yes, what database to use, what queries to give, what to do with that. There are a lot of interesting, easy answer problem that we all know how to solve. The catch is in, or the goal is in now doing the first phase, so that now a series of downstream tasks could be enabled. And how was it done? So the today's strategy, as I mentioned in the beginning, is about data, it's a data-driven intelligence. So what we did was we just looked at a set of matches available, videos available, and created a set of annotated videos and just learned from that. So you have an AI algorithm or a machine learning algorithm which is looking at this data, and of course, this today everybody want to keep such like a data, knowledge, everything open. So the paper is out, paper report is out, the data is out, like people can just play with it. So you can build like a solution. So you can build solutions that work on this data. Now with this, you know what to detect, where to do, everything that you can, the problem that you talked about can be solved now. So this is where the points that we mentioned in the beginning, the object detections, pose estimation, the action dictate, all those modules could be plugged in this data to give you the right analytics that you are looking for. And that is what enabled this video clip. This is the same thing that you saw a little before. So you should appreciate there's some text written at the bottom, what action, what they are doing actually. Now this came out, and as a university, we were writing piece of code in the lab and taking results and writing paper, the typical academic research that we did. And immediately we got a query from Star Sports. Oh, it looks like you have some paper and some technology. Is it possible to try it out? We were shocked. So we never thought the code that is written by students in the lab will work in the real field. Okay, so we had the triple IT with the vision of working on technologies that really matter. So we had a small team of product lab, they were bold enough to say that, look, we will just take the code from the lab and provide the service to the Star Sports. Let us see whether this is going to work. It was a litmus test on the technology. And so you can see on the left-hand side, so people went to Bombay and were at the studio running the code so that you can give a live, say that the match is happening, the live stream comes and you want to run this and provide some analytics to the commentators or the viewers. So here is an example.
In the second is a Trump match, of course. She's covered 218 meters in the match so far. Ardeshi, distance covered 94 meters.
Some very, very good net play. Well, there you go. That's an interesting one. Distance covered 269 meters. Okay. Well, we have nothing to compare that with. Oh, there you go. 264 meters. So they're all definitely gliding and sliding around that court.
I think we'll have to add the word winner to that as well. And Srikanth, he's traveled 270 meters, the duration of that first game. And when we look at Antonson's distance covered, well, it's 300 meters. And what that says is that Srikanth has done more with less.
Are these
in the second?
So this was as I mentioned, so how this academic research from the lab went into a pilot in the real field. Of course, we succeeded and we were able to meet their requirement. So now this needs to go. So as an academic institution, as a faculty member, researcher, we wish students take this forward or others take this forward. I continue to write my papers, teach my lectures, guide my students. That is what I do. So I mentioned a little before about how this academic research can be connected to the real field. So what we were trying to do. So I'll just play.
IIT Hyderabad Center for Visual Information Technologies has been doing pioneering research in understanding sports videos using artificial intelligence and deep learning methods to understand a player's performance, understand the game, even to the extent of automated generation of commentary. The research to market translation lab at IIT Hyderabad, the product labs, had taken this technology forward and piloted this at Premier Badminton League. And based on the initial success, we had decided to seed a startup through our Entrepreneur in Residence program. And now we have, from this intervention, a Matchday.ai, which is now raring to go to the market with the technology and the product.
By building on existing research work from IIT Hyderabad's labs. The technology that we built enables automatic data extraction from sports videos by using artificial intelligence and computer vision. The speciality of our product is that it requires no special equipment, can be done at a very low cost, and is highly scalable. Currently, we are focused on badminton and are actively engaging with Sri Gloria Gopi Kumar, who said that he sees great potential in the application of our technology, both for pro athletes as well as young aspiring athletes. Pro athletes can analyze their match videos for game assessment and also analyze opponent's game to build opponent-specific strategies. For training of young athletes, we are installing cameras in courts which will enable them to assess and improve their game by using tools which are on par with what pro athletes use.
So the idea here now is how this technology can be now taken to the a grassroots, a small coaching centers. Can you ever have technology which can now run on your mobile phone in the local courts? Okay, so coming back to the Federer story. So now you have this large number of matches or historic matches between, say, Federer or Nadal, or like a set of Djokovic. Okay, so you have it's interesting matches. Now you can actually use this technology to mine what has happened over time. What type of movements that they had before injury, after injury, when they come back, with age, against which specific opponent, how they prefer what. So there are a lot of interesting patterns that can be analyzed. And the set of things that we all are familiar with, such analysis on a discrete data that we collect in supermarkets, now gets applicable in the sports field. You can recommend now players what to do, what not to do. You can predict what is going to happen. You know the trends. You know what could expect in the future. So what they do over time, like I say, it can be analyzed. So in general, this sort of strategy of all the count, stats, score, it's very simple now. If you look at it now, once you are able to break the critical computer vision piece, a number of things that we all understand in terms of co-occurrences and patterns and outliers and strategies and many other things that you know can be directly extended to this. It opens up a new problem space, and I'm sure somebody or other in this space, in this audience, could take this forward or have interesting ideas in this space. We are actively looking for entrepreneurs who can take technologies from the lab outside.
Through the qualifying, reached the quarter-final before losing to the eventual champions Mohamed Hassan and Hendra Setiawan. And here they are, just 12 months later, having reached the final. Oh, goodness. Oh my goodness, he's fallen over.
These are not very easy problems for us. Funny videos or interesting videos.
Brutal.
Very, very complex. So is it all done? No. There are a lot of things that we are not able to break. Say from a pure technology point of view, I can show you a lot of open issues that we still have to solve. There are a lot of other non-technical issues in terms of this. So for example, this is a conservative community. So I made this remark in the beginning saying that, look, more technology has not gone. So it may look to be on the surface that technology has really gone inside. It has not. Big data repositories are usually proprietary. So it is not easy, no annotations. So you're leaving a humans to go through such huge repositories and learn and use this knowledge. And with the amount of data that we are seeing, it is clear that this is not going to happen. We are seeing the limitations of human digestion of such data and reuse of the knowledge from it. Not only that, every sport is different. So though you may say badminton, tennis, like a double, singles, everything has its own like a variations. Every player is different. So you cannot simply assume things are solved. There are and every court could be different. The way they position cameras could be different, and of course, some of them could be learned or adjusted or planned with the technologies and the results that we may have. Okay, another example, very interesting example here. Take the quiz. vertical positions.
Well, the surface is the most important thing in tennis, I guess.
Clay is typically the slowest of the three surfaces. On contact with the loose clay, the ball digs in, slowing it down and increasing its exit angle. This gives clay its characteristic high bounce. The flight of the ball is slowed even further by the loose clay particles, which catch in the fuzz of the ball and increase drag.
To play successfully on the hard court, you need to have a big serve, you need to have fantastic ground strokes, and you need to be physically strong.
Unlike on clay, the ball can't dig into the bouncy surface of a hard court. This means the ball keeps more of its speed and leaves at a high exit angle, making the average hard court medium fast and with a high bounce. But the hardness of the surface comes at a price. When the ball strikes a grass court, it bends the individual blades of grass, allowing bounce with very low friction.
Playing on grass is like the ball doesn't bounce at all. As soon as it bounces, it just slips.
The ball loses very little speed and the exit angle is the lowest of the three surfaces. Viewed in slow motion, the unique properties of grass, clay and hard courts are revealed. Just 5 milliseconds of bounce are enough to completely change the behaviour of a tennis ball and create 3 very different types of tennis.
So there are not just the player, there are other parameters or other players in this entire game like court, the surface. So we need to understand that too. Are the problems fully solved? No, there are still a lot of things to do. So if you look at most of this understanding that we talked about, we never saw the ball. So we're looking at predicting the ball by looking at a lot of evidences. With the type of frame rates that we may have in this camera, we may not be reliably seeing it. So there is a lot of other clues that the players use without really seeing the ball. Player action, location, movement, strategies. And there are a lot of interesting open problems, and we are not in a position to solve all of them today. And what I'm sure with the way things are moving, you can think of many of these problems will get solved in the coming years. To summarize, it's an exciting space. Many important problems can be solved with computer vision today. Many open problems, many promising applications in front of us. So what we have seen possibly is only like a couple of games, and there are a lot more number of possibilities where this or similar things could be useful and academically exciting. Very nice, cool thing for the students to work on with a lot of immediate applications. And this is possibly the time for connecting the AI, computer vision, machine learning to the physical world. And what we are talking about is the sensors and algorithms that can make this happen. So a lot of interesting future directions exist. So you look at, can you build a TT pole? So can you have a small device which is just kept on the side of your TT table where you can mount your mobile phone and get all the analytics that you really want? Good embedded system, good set of algorithms, good set of applications. You can have smart tables now. You can provide recommendations. You can get recommendations equivalent from or big experts. You can get such recommendations online. You can create a number of tool chain because you're working on large video data repositories. You're creating data that could be of use and there is an interesting algorithm development space. Thank you. I'll end here. I'll be happy to take any questions or comments from the audience. Thank you. I'll unshare the screen.
So we have the Q&A section, requesting students to either unmute and ask a question or post in the chat box.
Dr. Jawahar, good evening. This is Narayan. You can hear me?
Yes.
Okay. Yeah. It's very, very informative presentation. Thank you. I really enjoyed it.
Yes.
I was reading a article just yesterday about technology coming into umpiring and refereeing, which is probably the most prevalent today. So that was a very interesting article, and it ended saying that umpires and referees are not going to be out of job because there are 3 items missing, which is humanity, humor, and expertise. So these are the 3 things that mentioned. I found it very interesting. I'm agreeable to the first 2, but may not be the third one, expertise. I personally believe computers will get more expertise over the time, but I would like to hear your views on this.
See, I think I agree that the computers are not going to take over the humans. There is a role for umpires, there's a role for players, there's a role for coaches. They are not going to disappear. So I don't so this is the same doubt that we every time we have, isn't it? So if you look at when this MOOCs came into the picture, I think all the teachers thought that we are all going to be jobless. We now very clearly know that, okay, what are the limitations, strength and weakness of such an education system? And similarly, this sort of technologies have its own strength and weakness. So umpires will continue to have job. So they will have expertise. So there are certain type of expertise. So there's a catch. And say, as I mentioned, a lot of things that we are possibly not able to do that today. A lot of interesting decisions. I can see a lot of games where very complicated decisions were made by the umpires in the middle. It's an expertise which you never anticipated. The rules were interpreted indifferently. So there is a role. Is that what you meant, or is that?
Yes, yeah. I got. Yeah, thank you very much.
So we have to understand how do we coexist with technology. So if you believe if technology believes that, okay, look, we will just take over humans, or humans believe that we will keep the technology away from them, both are possibly not going to happen.
Yeah, very true, very true.
Yeah. And academically, the AI existing or working with human is a very, very interesting area that is going to emerge in the next few years.
Hello, Professor Jawahar. This is Ganesh. I'm calling from California, from the Bay Area. First and foremost, it's an awesome presentation and a lot of insights that you were able to share and then your students through the video. I was also so privileged to give the exact same lecture last year for the Gloria Gopi's annual event. So I'm in the autonomous driving space, and my company rather, not me personally, but my company. And I see a lot of parallels and similarities and challenges and opportunities between the sports arena versus the real driving on the cars.
Okay.
So my question is, twofold. For the sports arena, I understand how you have arrived at some of these conclusions, the qualitative questions and answers you were able to arrive at, because you have a data source, right? You have a humongous amount of videos and audio clips, video clips, you name it. It's all available on the internet.
Yes.
But when it comes to the autonomous driving car, the data doesn't exist. You have to create that data, right? in order to arrive at a certain pattern. So I'm just wondering, have you thought of at least doing some research, if you haven't done it already, in solving that problem? I know many companies, including mine, is also working. There is no perfect algorithm solution out there, because always you will find some, additional use cases that you haven't even programmed or thought through. And we can't afford to do that, right? It's a very, very, how should I say, it's a safety-enabled use case. Just wondering your thoughts on, have you thought about doing some research if you haven't done so already? So I'd love to hear your thoughts.
Very, very, very nice question. I was just weighing between the sports talk or the road safety or autonomous driving talk for today.
I'll enable my video too, so you can see me.
Yeah. So is it okay if I show 2 small video clips?
Please.
I don't know. I hope the organizers may allow me to show.
Sure, sir. Please go ahead.
I just want to show you 2 small video clips from this. Like you asked the question, so you asked so I'll give you 2 video clips so that you get a feel of that.
Yeah.
I want to show you. So this was the mention was more of autonomous driving. I just want to show you more like an immediate need for the country in terms of where is it? I just want to show you another video clip, which possibly is more relevant. So just like so autonomous driving is an application for the rich. For India, possibly we need something more important.
India has one of the largest road networks in the world and is emerging as the fastest growing network. With more vehicles on the road, safety is now crucial than ever before. To help address this, the Government of India is aiming for a 50% reduction in road fatalities by 2025. In Nagpur, the geographical center of India, a pivotal project is taking shape. For the first time, artificial intelligence will act as a force multiplier and transform road safety engineering. Presenting iRaste, intelligent solutions for road safety through technology and engineering, a project that aims to achieve up to 50% decline in road accidents in Nagpur city. Project iRaste is a unique partnership of industry, academia and government and is initiated by Nagpur Municipal Corporation, CSIR, CRRI, Mahindra and Mahindra, NI, IIIT Hyderabad and Intel. It brings in a holistic, safe systems approach to aspects of vehicle safety, mobility analysis and infrastructure safety. Advanced Driving Assistance Solution, or ADAS, will offer an economical way to enhance safety of fleets and road users. ADAS alerts, alongside driver assessments and training, can notably improve driver performance. Mobility analysis will monitor dynamic risks of the entire road network to define grey spots. Preventive maintenance of such risky stretches will prevent black spots before they claim lives. Infrastructure safety will design engineering fixes for existing road black spots.
Yeah. So the idea is about like how do you use the technology for the autonomous driving. So people have been seeing the different levels of autonomy in ADAS and autonomous driving. Like, can you go one level further in talking about how this technology can be useful for road safety and improve the citizen life?
Yeah, there's no perfect solution or even semi-perfect solutions out there that we can put it on the road safely. I mean, India is again for tomorrow, because the road conditions and the environment is such complex. I personally don't think that even the technology is there to capture every single aspect of the road movements in India. So we also use the Intel's Mobileye computer vision technology for our cars. So it's a level 2 ADAS. So we're developing level 4 AD. So we hope to deploy that sometime this year, middle of this year. So the challenges are very similar as you explained in the sports versus just a different use case. But the main challenge is the data collection, because every road, every operational design domain, everything is different in the world. So it's encourage, in fact, our students from our college who are aspiring to come up with and then try to solve this problem. I think it will be a huge value, and the world needs it, right? And I hope this will be an inspiration from your speech, sir, for our students and the faculty supporting the students there at GCT to work on this computer vision problem.
The solutions will have to come from the local community.
It absolutely has to come from it. Yeah.
Yeah. Sorry, we did a detour from the talk. Like, any other comments, questions? I think I can. Technical, non-technical.
Hello, sir.
Yes, please go ahead.
It was really a very interesting session, sir. My question is not too technical. Sir, how do you got this much interest in computer vision? What is the most exciting thing you have about computer vision?
See, I'm born to do computer vision. My name is CV Jawahar. Yeah.
That's interesting, sir.
Yeah. See, whatever area you pick, you just continue to do that, isn't it? I think I should also thank the teachers, who possibly induced some of this even when early days. Yeah.
Thank you, sir.
Yeah, Jawahar.
Yes. Oh, hi.
No, it's not a technical or anything, but quite out of interest. So for each sport, initially, you will have to learn every fine detail about each and every sport. And I think that by now you might be a master of all those sports, right?
No, just like any teacher, we assume the students will master it. So I don't think anybody who knows me from the days will think that I will play any game or I know any game. Yeah. So there are a lot of domain knowledge. Indeed, there are a lot of domain knowledge need to do.
Yeah, that's what I asked. Yeah.
And these are popular ones, so almost everybody will know. I think today.
Yeah, thank you. It was very interesting. Thank you.
Thank you. Yeah.
Hi, sir. Nikhil here. Is there any sports which don't have the application of data science or AI?
I have no idea. Why you want to play that game?
No, just almost everything we have covered. So, like,
No,
just
no, these are only few. These
want
are
to know
only
whether you have some thought.
These are only few.
Okay.
Yeah, there are a lot of things which we don't know. So
Okay.
we say, look at if you notice throughout my talk, like I was mostly using broadcast videos or freely available videos on YouTube or other places. I've not even gone or except when you now talk about deploying this in the badminton courts, etc. We are most of the time we are working on just things that are publicly available.
Got it. Got it.
So that way we are limited by what the people are providing. So
Okay.
to go beyond it requires more investment and more like a business oriented research. So this is more like fun oriented research.
But the star sports and all are involved, right? So business will come for sure.
Yes. Now they can provide possibly more data. Yeah.
Yes.
So these are all nice things for the students to play with. They like it.
Thank you. It's a great session. Thank you.
Jawahar, I am Jayan. Actually, I have one question. Actually, you have talked about processing the images and the video to get some information, and can we integrate it with robotics and can have a player who is better than Messi in taking or in playing football? Is there a possibility of that?
So see, I don't know whether you are aware of something called a robo soccer. So this started many years back as a formal thing. You can look at on internet what happened as a robo soccer when it started. So it was mostly still, I don't think it is still reached the level of a player. It is possibly the strategy wise robo soccer is quite good. So that is what it learned. So if you look at the example that I gave you, the bowling machine, that may be the nice thing that you can think of. If we can build a bowling machine, which can spin it. If people, today's one don't even spin. So you can do something like a bowling machine, which can understand the weakness of the batsman. So now today people talk about such training methods itself. Can you adversarially train? So can you train in such a way that you beat and then the batsman plays better? So you build a game between two parties. One may be a human, one may be a machine, and then play each other so that one beats the other and learn better, improve it. So this is a strategy that people now talk about everywhere. This is surely applicable here. What has not happened is enough is the development of the electromechanical systems. So if you want to build today the electromechanical system that need to bowl, or that need to walk, or that need to do games by moving this fast, I think the electronics has not reached there. Mechanical has not reached there. So this is a very important area where we are lagging behind. So there is a lot of things for the robotics people to do to catch up.
Okay. Thank you, Jawahar.
Professor Jawahar, ഒരു ചോദ്യം ചോദിച്ചോട്ടുണ്ട്. ഈ സംഗീതം ഉപകരണങ്ങൾ ഇപ്പൊ നമുക്ക് ഇന്ത്യയിലാണെങ്കിൽ ഒരുപാട് ഉസ്താദുകൾ ഉണ്ടായിട്ടുണ്ട് ഇപ്പൊ ഒരു കാലഘട്ടത്തിൽ. ഇപ്പൊ അടുത്ത കാലത്തായിട്ട് ഇങ്ങനെ ഉസ്താദുകളൊന്നും വരുന്നത് കാണാറില്ല. നമുക്ക് സംഗീത ഉപകരണങ്ങൾ ആ സ്പേസിൽ വല്ല ആപ്ലിക്കേഷൻസും പറ്റുമെന്ന് അറിയാൻ വേണ്ടിയിട്ട്. Are you there in that space?
So I don't do anything. I don't have much knowledge in that space, but I think there is a lot of things that one can do by understanding the past music, but like renderings, etc. And you can also think of how to be creative. And you can also use it for teaching. So how do you teach people to play certain things? So I was part of a project, Ego 4D, a motivating example. I don't know. Can you, say for example, like wear a glass and walk and see how do you play a drum? How do you teach? How do you see from a teacher's perspective? How do you get a first person perspective when you learn? ഇത്തരത്തിലുള്ള പല കാര്യങ്ങളും ചെയ്യാനുള്ള സാധ്യതകളുണ്ട് ഇത്തരത്തിലുള്ള ഈ മ്യൂസിക്കിലും അല്ലെങ്കിൽ മറ്റു പല ഏരിയകളിലും.
Hi, sir.
Thank you for the lecture. It was engaging and informative. My question is, when we say that machine learning helps to analyze the games much more, track the moves exactly, and helps in prediction, isn't there another side to it which affects the thrill of the game? Like, one of the factors which makes the sports interesting is its unpredictability, right? So we don't know what is going to be the next move or how the opponent is going to react to that. So how much would technology affect the ethics in the sports field?
See, I don't know whether you noticed in my one of the first slide what I mentioned is about like there is something that you are going to kill or you are going to lose the thrill of game. I just want to share. You can see this slide now, isn't it? So
yes, sir. Yes, sir. Yeah.
Last point, the sports is a PP6. Sports lovers worry about will the tech spoil the sports? It could become more mechanical. It could become more strategic. It could become more competitive. And of course, you see the competitiveness today. A competitiveness like a natural, like the issues. That's sports. Sports competitiveness.
Okay, sir. Thank you.
Thank you. Any other questions, comments?
I hope there are no more questions from the audience. So let me proceed to the vote of thanks session. Actually, it was a very inspiring lecture, truly speaking. It was intended for a hybrid type of audience, but Dr. Jawahar, he has given too much insight into the field of computer vision, the possibilities, and how we can connect it with problems which are very relevant for the society. So I sincerely thank him. And as a teacher, I feel that one who is a master of technology can only, such a person with all inside out knowledge of a subject can explain things in such a simple manner, which is acceptable or which is digestible for a person who is from a different field or who has little knowledge in that area. I am from speech field, and this talk was excellent for me to understand the possibilities of computer vision. How can we use computer vision in real life applications? So on behalf of GC Thrissur, Alumni Association, ECE Alumni Association, and Government Engineering College Thrissur, I sincerely thank Jawahar for delivering a lecture. And as a token of our appreciation, I would like to present him a virtual memento. So this is our token of appreciation for this lecture, which was very insightful. And I hope this screen is visible to you. Can somebody respond? Hello?
Not yet.
Not visible.
No, sir, it's not visible as such.
Okay. I think that one second. There is some problem.
Enabled, right?
1 second. It will come.
Now it is coming.
So it's coming. It's coming.
Okay. So
your desktop, not
Okay. I hope it is visible now.
Now I can see.
Okay. So rather than words, I am using an image. I am using an image to convey our sincere thanks to you. So proceeding further, I am very thankful to our principal, Dr. Ranjini Bhattatripad, who was actually a driving force for this program. I thank her for her support extended to this program. I thank Dr. Nausaja and Dr. Professor Krishna Kumar, Professor Burunda, Professor Tajuddin Ahmad, who are all behind this program to organize it in various levels. I am thankful to all the dignitaries who are present in this program, who attended this program from various places in this Zoom live as well as in Google, this YouTube live streaming. So I thank each and every participant who attended this session. And to mention some more names who worked for this program, I would like to thank Sijo Vadakan and Rahmatullah from Central Computing Facility GC Thrissur, who were helpful in setting up the Zoom and all these connectivity issues in a very good manner. And I am also thankful to Jay John, GC Kannur, who actually designed all the posters, all everything related to the communication, poster design, everything he did it voluntarily. I am very thankful to him. So I thank one and all who attended this program, and I wish everybody a very fruitful experience. And for researchers, I think this lecture can be taken forward, and we can try computer vision applications for students. You can do it in your main project. It is very interesting, and I think it's a very wide area where we can attempt to solve problems which are having real practical relevance. Thank you. I request Nausaja to take over and to formally conclude this session. Thank you.
Thank you, Jayan.
So we have reached the concluding session. So thank you one and all once again for attending this session and very actively participating in the Q&A session as well. So thank you all. Sir, Dr. Jawahar, it was really very relatable to people even not from the AI or ML background. So I could very easily relate with many of the examples. So it was in fact a very interesting session. And finally, your observation regarding like how CV is connected, your initials are connected with computer vision is also equally interesting. So it looks like it runs in the family as a whole. So it was really interesting and spot on, in fact. So with this, let's conclude the session. Thank you all who have attended this once again, and good night. Take care.
So thank you surely for inviting, and I'm really missing a visit to a campus, which is overdue. So, bye.
Sure, sir. Maybe next time. Bye.
Disconnect it.
ചെയ്യാം സിജോ അതെ സ്റ്റോപ്പ് ചെയ്തോളൂ.